So let's just do another example here. So example 3. We will let f of xy equal to sine of x squared plus y. Okay? And we will do, well, let's just run through them. Let's run through all of them. So we have d1. The derivative with respect to x. We have cosine x squared plus y times 2x, which we'll write, again, it's sort of, I mean, you can leave it like this, it's not a problem, but it's traditional to sort of bring all of the functions and stuff forward and leave the trigonometric function to the end. So 2x times the cosine of x squared plus y. Okay, so d2 equals the cosine of x squared plus y times 1, which equals cosine, because it's the derivative of the inside, right? Chain rule. Cosine of x squared plus y. Now let's do, just for the heck of it, let's do d1 squared, which is the same as d1. So we have d1 already. Now we're going to differentiate this with respect to x. So this is going to be, I tend to pull my constants out, so I'm going to pull this out, and it's going to be a power rule, x times the cosine of x squared plus y. So it's going to be this times the derivative of that. So it's going to end up being minus x times sine x squared plus y times 2x plus that times the derivative of that, which is, or this times the derivative of this, which is just 1. Again, I pulled the 2 out. So it is cosine of x squared plus y. So again, the idea is just be really, really careful and go really slowly. There's no hurry. I mean, the idea is to be right, not to be able to finish quickly. And when we put this together, we end up with, so the 2 and the 2, this is a times, not a minus sign, you end up with minus 4 x squared times the sine of x squared plus y plus the cosine of x squared plus y. So that is the derivative of the derivative. Derivative with respect to x of the derivative with respect to x. d1 squared, d1. I really, really love this capital notation, and I love not writing the f's. Okay. Now let's go ahead and do d2 squared. So d2 squared, which is d2 of d2. When we do that, we end up with minus sine of x squared plus y times 1, so equals minus sine x squared plus y. And I hope you guys are checking this. Now let's do d1, d2. When we do d1, d2, we end up with, in other words, we've taken d2, now we're going to take d1 of d2. Minus sine x squared plus y times 2x is going to be minus 2x sine x squared plus y. And now we'll do d2 of d1. In other words, we've done d1 first. Now we're going to do d2 of that. We get minus 2x times the sine of x squared plus y times 1, which equals minus 2x the sine of x squared plus y. Well, what do you know? This ends up being the same as that. This mixed partial is the same as that mixed partial. The order is irrelevant, but it's 1, 2, 2, 1, and that's it. So mixed partial derivatives of higher order are the same for functions of several variables, provided, so the order doesn't matter, but provided that all of the particular variables with respect to which you're differentiating are there. So 2, 3, 1, 3, 2, 1, 1, 2, 3, 1, 3, 2, all of those will actually end up being equal. And I personally think that's absolutely extraordinary. Thank you for joining us here at Educator.com. We'll see you next time for some more multivariable calculus. Take care.